Welcome to AI Podcast. I'm Ben, and with me is Maya. Today we're unpacking a paper called Self-RAG, Learning to Retrieve, Generate, and Critique Through Self-Reflection. Quick headline first. Self-RAG trains a language model to decide when it needs outside evidence, how to write the answer, and how to check its own work. That leads to more factual responses and better citations than typical retrieval-augmented systems, and on several benchmarks it surpassed ChatGPT baselines, especially for factuality and citation precision.
Nice. So the elevator pitch is smarter retrieval plus a built-in self-check, and that translates into more trustworthy answers.
Exactly.
Who's behind it?
Lead author Akari Asai with collaborators Zeqiu and Yizhong Wang at the University of Washington and the Allen Institute for AI, Avirup at IBM Research, and senior author Hannaneh Hajishirzi of the University of Washington and AI2. It first appeared on Archive in October 2023 and was published as an oral at ICLR 2024.
Got it. Before we dive into how it works, what problem are they really trying to solve?
Two long-standing issues. First, large language models can hallucinate, especially on long-tail facts or when you ask for sources. Second, classic retrieval-augmented generation tends to pull a fixed number of passages every time, whether the model needs them or not. That can introduce irrelevant context and still doesn't guarantee the answer is actually supported by the citations.
So even if you dump in a bunch of snippets, the model might cherry-pick or ignore them.
Right. And it might confidently cite something that doesn't truly back up the claim. Self-RAG aims to make the model aware of when retrieval helps and whether the answer is grounded.
How did previous methods fall short?
A lot of prior systems glue together separate parts: a retriever, a re-ranker, sometimes tool calling, and then an instruction-tuned generator. Those pipelines can be brittle, they always pay the retrieval cost, they are sensitive to noisy passages, and the attribution quality is uneven. You can get fluent answers that aren't properly supported.
Okay, so what's the core idea in Self-RAG?
The authors add special reflection tokens to the model's vocabulary. Think of them as small control signals the model learns to produce. There are tokens for deciding whether to retrieve more evidence, and tokens for critiquing what's going on. During generation, the model can decide to retrieve, judge whether a passage is relevant, and assess whether the current draft is supported and useful.
So the model narrates its own process in a way it can act on.
Exactly. At inference time, decoding pays attention to those signals. If the model predicts a passage isn't relevant or a continuation isn't well supported, the search steers away from that path. You can also dial how strict you want the model to be about support versus fluency.
I like that knob. Sometimes you want elegant prose, other times you want every sentence anchored to a citation.
That's the idea. Another practical detail: they don't keep a separate critic running during inference. They first train a critic offline to annotate training data with reflection tokens, partly using guidance distilled from GPT-4, and then they train the final generator to produce both the answer and the reflections on its own.
So at deployment time, it's just one model that knows how to reflect.
Right. No extra component in the loop.
What did they test it on?
A mix of open domain question answering and long-form generation. Examples include PopQA for long-tail facts, PubHealth for fact-checking, Trivia QA, and long-form tasks like writing short biographies with source grounding and answering questions that require explicit citations, such as ASCO. They used Llama 2 models with around 7 and 13 billion parameters as the base and paired them with a strong, dense retriever. Evaluation looked at accuracy for short answers, factuality for long-form writing, and citation quality measures like precision and recall.
And compared to what?
They compared against non-retrieval baselines like standard Llama 2 and ChatGPT without extra documents, and against retrieval-augmented baselines that always pull passages. They also looked at systems that call tools or rely on fixed retrieval pipelines.
So how did Self-RAG do?
Broadly better than standard RAG on the same base models, and on several tasks, it surpassed ChatGPT baselines. The biggest wins were where grounding really matters. For long-form biographies, it produced more factual statements. For citation-required question answering, it delivered higher citation precision, meaning the cited passages more reliably supported the claims. It didn't win absolutely everywhere, but the gains on grounding and attribution were consistent.
Did they dig into why it helps?
Yes. Ablation studies showed that removing the self-assessment signals during decoding hurts citation quality. Forcing a basic one-passage setup, like a simple RAG pipeline, lowers performance on citation-heavy tasks. They also found the retrieval decision is task-dependent. Some tasks barely need retrieval, others suffer if you hold it back. The reflection tokens let the model adapt to that.
From a user's point of view, how does that controllability feel?
Imagine a slider. If you weight the support signal more heavily, the model becomes stricter and cites more precisely, though the prose can be a bit drier. If you loosen it, you get smoother language, but accept a small risk of weaker grounding. It's a trade-off you can tune.
All right, time for a critical take. What should listeners keep in mind?
A few points. First, part of the supervision for the reflection tokens came from GPT-4 before being distilled. That's practical, but it introduces a dependency on a proprietary model for creating training signals. Second, some human evaluations were relatively small, so we should be cautious about over-interpreting fine-grained preferences. Third, there's extra inference complexity. Even without a separate critic at test time, you still have retrieval calls and a more involved decoding process, which adds latency compared with a pure language model. Finally, results focus on Llama 2-sized models and a specific set of benchmarks, so it will be useful to see broader domains and newer base models.
So it moves the needle on trustworthiness, but it's not a silver bullet, and it may cost a bit more compute.
Exactly, and the authors are clear that unsupported statements can still slip through. The difference is that self-RAG makes support more visible and gives you a way to steer how strict you want it to be.
What would you like to see next?
Co-training the retriever with the generator so retrieval itself is optimized for these self-assessment signals. A richer set of reflections like tokens that flag contradictions or uncertainty. On efficiency, better caching or early exit rules to keep latency down. And broader evaluations in high-stakes domains, along with user studies to see whether the transparency from reflection signals improves trust and workflow.
And maybe more open supervision so people don't have to rely on GPT-4 when they reproduce the results.
Exactly. More open reflection-labeled datasets would help with reproducibility.
Before we wrap, give me the practical takeaway for builders.
If you use retrieval-augmented generation and care about factuality and citations, self-RAG is worth trying. It unifies 3 decisions inside one model: when to retrieve, how to write, and how to judge support. It also gives you a control knob to trade fluency for stricter grounding. The code and models are publicly available.
Clear, calm, and useful. Thanks, Ben.
Thank you, Maya. That's it for today's AI podcast. See you next time.